In this video, we will discuss the radio communication in detail. So, first of all discuss, what are radio waves? Radio waves are electromagnetic waves that propagates in the form of electric and magnetic fields, just like light waves. But the difference between light and these radio waves is that they differ in frequency and wavelengths. The figure shows the complete electromagnetic spectrum. The visible light spectrum lie in the middle of electromagnetic spectrum. The first color in visible spectrum is red. Thus, below the red is infrared, as the prefix, infra, suggests, and the last color is violet. Thus, above the violet is ultraviolet as the prefix, ultra, suggests. The radio waves has much lower frequency than visible light, and play very important role in wireless communication. The other parts are also used for communication, such as microwaves are used in radars, inter-satellite and deep space communication, etc. And infrared waves are short range and used in remote control of television, keyboard, mouse, etc. and security systems. But in this video, we will only focus on radio communication. You are familiar with the various types of radio communication, such as mobile communication, Bluetooth, Wi-Fi, FM, radio, television broadcasting through satellites and many more. All of these communication applications differ in frequency ranges. For example, the frequency range of mobile communication is from 800 MHz to 2600 MHz, that consist of 2G, 3G, and 4G bands. Bluetooth frequency is around 2.4 GHz. Wi-Fi uses either 2.4 GHz or 5 GHz bands. Radio or amplitude modulation frequency range is from 535 kHz to 1605 kHz. FM frequency range is from 90 MHz to 110 MHz. And television channels frequency range is from 950 MHz to 2150 MHz. So, let's discuss all of these applications one by one. So first of all discuss radio. In our previous video, we have discussed that if two persons are distant apart, then, the sound of one person could not reach the other person because the sound waves cannot travel much distance in air. So, at radio station, sound is converted into radio waves and transmitted in space with the help of antenna. These radio signals are received by the radio antenna and converted back to sound. But, the question is, how the sound is converted into the radio waves. This is achieved by modulating a sound signal with a high-frequency carrier signal. This process is called modulation. Each radio station transmitted the radio waves at different frequency. Imagine, if they all transmit the radio waves at the same frequency, then, they will all mix up, and you will not be able to hear and understand them. Actually, they all use the different carrier frequency. You can only hear one station at a time because, when you tune a radio receiver, it only receives a carrier wave of one frequency. This is the functional block diagram of radio. We can divide it into two parts. One part is called transmitter and the other part is called receiver. At transmitter end, the microphone converts the sound signal to electrical signal, and then this signal is modulated with the high-frequency carrier signal. Then, this modulated signal fed to radio frequency amplifier. After amplification, the amplified signal is transmitted to space with the help of transmitting antenna. At receiving end, the radio frequency signal is received by receiving antenna, and this signal is filtered, amplified and tuned. Then this radio frequency signal is demodulated with the same carrier frequency by which the sound signal is modulated at transmitter end. Then this baseband signal is fed to speaker to produce the sound signal back. Remember some terminologies. Sound signal need to be modulated, so it is called modulating signal. After modulation it becomes modulated signal. At receiving end, we need our sound signal to listen. Because we could not hear a radio signal, as this signal is of high frequency signal and human ear can only hear up to 20,000 Hz. So, this high frequency is converted to low frequency signal. This conversion process is called demodulation. To understand modulation, take an example. A person wants to move from Lahore to Karachi. As the distance between these two cities is 1,200 kilometers, it is hard to travel by foot, but if he travel by plane, then he will reach his destination easily. Same is the case with sound signal. It cannot travel much distance in air. It needs a carrier wave just like man needs a plane. As the carrier wave is radio wave, which is an electromagnetic wave and travel with the speed of light. In this way sound signal reach its destination in no time. Let's discuss the modulation process in detail. In modulation, either amplitude or frequency of carrier wave is varied proportional to information signal. There are many types of modulation, but we will discuss only two types here: amplitude modulation and frequency modulation. In amplitude modulation, amplitude of carrier wave is altered proportional to modulating signal, while on the other hand, in frequency modulation, frequency of carrier wave is altered proportional to modulating signal, while the amplitude of the carrier wave remains constant. Details will be discussed in the next video, so keep in touch.